look at x. So we're going to talk about 2x squared plus 7x minus 3 all over x minus 2. And there's everything. All right. So let's talk about this for just a second. What's different about this problem than all the other ones that I gave that we did yesterday?
You have to divide.
We don't know that yet. I mean, you looked at the answer, right?
There's like more digits in the numerator than the denominator.
The top's too big,
No.
right? Can everybody see that? Right? Like everything that we dealt with yesterday, the bottom, the derivative of the bottom was kind of sitting on top. That was kind of the main idea. And anytime you see a fraction where the top is either equal or bigger than the bottom, we don't know how to handle this, right? So I want to make sure you understand that we don't know how to handle it looking like this. And so what we need to do is change the way it looks. And how we have to change the way this looks is we have to divide. So, here's our algebra step. Our algebra step is I'm going to take x minus 2 and divide that into 2x squared plus 7x minus 3. And let's see, I put a number here, so that's a 2x. That's going to give me 2x squared minus 4x. Change the signs. Did I do that right?
Is this long division?
Yes, this is long division.
I haven't done this in a while.
What?
I haven't done this in a while.
I know, yeah, a long haul, because you probably didn't do it that much last year either. Did I mess up?
Or you're supposed to change the signs. Right?
Yes.
Okay.
Yeah, I changed the signs. So then we get this cancels, so I get 11x minus 3. So then I put plus 11, so I get 11x minus 22. Change the signs here, and so this cancels, and this gives me 19. So I end up with plus 19 over x minus 2. No, I have a feeling I made a mistake in copying somewhere. Because the numbers, I thought I did the same problem second period, but the numbers were nicer. All right? All right? So there's our long division, and here's what's happened. That was supposed to be a 3x. Where did I mess up? Did I not
It's
cut?
because if you multiply 2x times negative 2 would be negative 4.
It would be 3.
So it's negative 4.
I know, but then you change the sign, right?
That's the only way you can get 3.
Yeah, I know. It was maybe, it doesn't matter. Okay. So then what we've done is this now becomes the integral of 2x plus 11 plus 19 over x minus 2. And now the question is, can you take the integral of this? Like, what's the integral of 2x?
X squared.
X squared. What's the integral of 11?
11x.
11x. And what's the integral of this?
14. Is that a
That's a 19, sorry.
That was a 19. Oh, okay.
Are we okay? It's 19 natural log of x minus 2. So this is going to be plus 19 natural log of x minus 2. Did everybody see how that worked?
Yeah.
So anytime you see a fraction where it's top heavy or balanced and the derivative isn't sitting on top, you have to change the way it looks. And the way you change the way it looks is this long division. And that's actually what happens in problems 15, 17, and 19. Right? You have to change the way it looks. So here, let's look at 19. The calculus for 19 isn't hard. X to the 4th plus x minus 4 over x squared plus 2. So can everybody agree that the top is bigger than the bottom?
Yeah.
And so anytime the top's bigger than the bottom, we have to change the way it looks. So I have x squared plus 0x plus 2, divide that into x to the fourth plus 0x cubed plus 0x squared plus x minus 4. That stay on the screen, yes, right? You gotta have all those placeholders in there, which is a bit of a pain. So what times what gives you x to the fourth? So this is x squared. I get x to the fourth plus 0x cubed plus 2x squared. Change the signs. And that's convenient. So I get minus 2x squared plus x minus 4. Now I need a negative 2. When I do this, I get negative 2x squared plus 0x minus 4. And now when I change the signs, that cancels, I'm just left with x. So I have plus x over x squared plus 2. So the painful part of the step is the long division. Once you do the long division, the rest of it isn't so bad because this is now the integral of x squared minus 2 plus x over x squared plus 2. And once you get here, I don't think it's so bad. Now you just take the integral term by term. So, you see, x cubed over 3, what's that, minus 2x. And that's a little trickier to do in your head. What's it going to be? Perfect, right. Plus 1/2 natural log of x squared plus 2 plus c. And what I really like is, like, if you've been thinking about taking integrals the way we've been doing it, this can be easily done in your head. Getting from here to here isn't so bad. If you're still doing the u substitution stuff, that's way harder. Okay, does this make sense? I didn't ask if you liked it, because typically high school students don't like doing the long division.
Not in a long
Yeah.
time.
I like the long.
Really? Yeah.
Fan.
So, all right, are we okay with integrals involving logs? All right, so today we're going to revisit something. So if I give you e to the 5x, what's the derivative of e to the 5x?
5 even 5.
Perfect. E to the 5x and a 5, right? So the interesting thing about e to stuff is the derivative of e to stuff is e to stuff with some extra things around it, right? So what if I asked for the integral of e to the 3x? Well, let's think about what we're trying to do, right? You want to think of something here that when you take the derivative, you get this, right? Well, what would be a reasonable guess? What could I put here that the derivative is going to give me e to the 3x?
1 over 3 times e to the 3.
Don't even worry about the number. Can we agree that e to the 3x would be a reasonable guess?
Yes.
Yeah.
Does that make, right? So if we can look at this and say, well, I think it's going to be e to the 3x. When I take the derivative, I get e to the 3x times the 3. So what do we need to do to fix it?
Divide by 3.
Divide by 3. And so this is going to give me e to the 3x over 3 plus c. Does that make sense? Remember, the goal of an integral is give me something that when I take the derivative, I get this. That's the goal. All right. So, what if I give you the integral of 5x e to the x squared? What do you do here? First, does the 5 do anything?
No.
No, it's just decoration, right? So you ignore it. What's a reasonable guess? Are we okay with e to the x squared? So in my mind, when I look at this, it's like I ignore the 5, right? Because I know that's just decoration. Anytime you're multiplying by number, it's just decoration. So if I ignore the 5, then I can write this as, my guess is going to be e to the x squared. And when I take the derivative, right? So what do I get? E to the x squared times 2x. What are we off by? Oh no, we're ignoring the 5 altogether.
1/2.
Everybody see we're off by a 2?
Yep.
All right. So we're going to divide everything by a 2, right? That's our answer. Our decoration's still there, so I end up with 5 over 2 e to the x squared plus c. Now, let's see what we know about all this. What's wrong with this problem?
You don't have the X that you can.
Did everybody see we have an issue with this? Did everybody see we have an issue with this problem? Like, we can't take the integral of this because we need that little x off to the side and we don't have it. So just make sure of that.
Wait, that's just not possible, we just don't know how to do it.
You won't know how to do that in this course. I'm trying to think if I know how to do it. That's the trick. I can give you anything and you can always take a derivative. You can't always take an integral. I mean, there's a whole course called differential equations, which is basically fancy ways of taking an integral, where they learn all sorts of techniques. I don't think we can take the integral of that. I took differential equations 30 years ago and I don't remember it. So now try this one. What's the integral of e to 1 over x all over x squared? If you rewrite this with negative exponents, this gives you the integral of e x to the negative 1 times x to the negative 2, doesn't it? Huh?
And then thinking with that and like what I just.
What's a guess? What's your guess?
X of the negative.
E to the
E
x.
negative.
E.
Your guess is going to be e x to the negative 1. And let's take the derivative and see how close we are. So that's e x to the negative 1 times negative x to the negative 2. How close is that to what we want?
-1.
We're off by a negative. So I divide by a negative 1. And so my answer is going to be e to the 1 over x, a negative, plus c. So here's some friendly advice. Anytime you see e to stuff and you're asked to take, no matter what's sitting around it, a reasonable guess is e to stuff, right? Everybody understand that? A reasonable guess is, okay, well, I'm just going to guess e to stuff, and I hope when I take the derivative, I get what's sitting around it. And 90% of the time, that's exactly what happens. All right? Oh, here, let's do a little more. This may be painfully obvious to some. But what if I gave you the integral of sine x e to the cosine x? What's your guess?
E to the
Cosine
cosine.
Right.
E.
Yeah. E to stuff, right? So I get e to the cosine x, and when I take the derivative, I get e to the cosine x times a negative sine x. What are we off by? A negative. All right, so I need to divide that by -1. So my answer is negative e to the cosine x plus some constant. A little easier to see?
Yeah.
Okay. Like, typically stuff with e, I think it's easier than identifying something with a natural log. Because when you see the e, it's like your eye sort of focuses straight on the e. Because that's kind of what you're looking for. So, what if I give you, let's do the integral of e to the 2x plus 4e to the x plus 3 all over e to the x.
Is that e to the x or 3 to the x?
E to the 2x.
Alright, good.
So what do you do?
Is this the long division?
Easier than that. What do you do every time you have multiple terms on top and a single term on the bottom?
Oh, split it up.
Split it up. Isn't that what's happened?
Yes.
Every time you've had something, it doesn't matter what it is, right? If you've got a bunch of stuff on top and a single term on the bottom, you break it up. And so when you break this up, you end up with, this is the integral of e to the 2x over e to the x plus 4e to the x over the x plus 3 over e to the x. All right, let's look at some algebra here. Well, e to the 2x over e to the x, what is that going to be?
E to the x.
Because you subtract exponents. So that's going to give me the integral of e to the x. We okay, the e to the x is canceled there? So I get a plus 4, and then I'm going to rewrite this as plus 3e to the negative x. Now this doesn't look so bad, does it? What's the integral of e to the x?
E
E to the x.
E to the x, integral of 4,
4.
4x, and what's the integral of 3e to the negative x?
Negative.
Negative.
Negative 3e to the negative x. Plus, I guess I probably should rewrite it and say that's e to the x plus 4x minus 3 over e to the x. Does that make sense?
Yes.
All the stuff we've been using, we figure out ways to sort of intertwine them all. Well, let's see. What if I give you the integral of e to the x over 1 plus e to the x? What's your guess? Is the derivative of the bottom sitting on top?
Yes.
Everybody see that? The derivative of the bottom sitting on top? So we end up with natural log of 1 plus e to the x. And that's it, isn't it? Have you noticed that your derivative skills have gotten a lot better?
Yeah. Definitely.
Yeah, that's really what's happened, right? Last semester, what happens is you learn algebra. I know it looks like I'm teaching how to take a derivative. What you really learn is algebra. This semester, it looks like I'm teaching integrals. No, what you're really learning is how to take a derivative. Like, your ability to take a derivative is so much better now than it was in November. And, I guess what if I gave you the integral from negative 1 to 0 of e to the x cosine of e to the x? What's your guess?
Yeah.
No.
Sine.
Oh, yeah, never mind.
Yeah. Is everybody okay? Our guess here is just going to be sine e to the x. We all see that the derivative of this is exactly what we're looking for.
Yeah.
But I need to talk about this. So we're going to evaluate from negative 1 to 0. So I want to talk about how you compute this. You plug the top number in, so e to the 0 is 1, so this gives me sine of 1. Plug the bottom number in, that's going to give me sine of e to the negative 1. And I guess if I write this down, I end up with sine of 1 minus sine of 1 over e. The reason I wanted to actually do this, believe it or not, that's the answer they want. Like, don't worry about trying to type that in a calculator, right? This is the answer they want. You don't know what sine of 1 is on the top of your head. I don't know what sine of 1 is. Wait, let me see if I can guess. If your calculator's in radians, I bet it's 0.76.
I got it.
Make sure your calculator's in radians.
I want to be the one to see this joke.
0.7, maybe 7.8. Make sure it's in radians. What? How close was I?
He wants to
0.84.
say.
Oh, dang. And I recorded that. I was so wrong. Okay.
Okay, you're close.
Probably
Close
better
enough.
than
Okay. Okay. All right. So, all right. But you know, your answers can look like this. And the same thing when you have logs and you plug in like a 1 and a 2, your answer could be log 2, natural log of 2 minus natural log of 3. That's your answer, right? So just be aware. I'm very serious. Like if this was a multiple choice question, this would be an answer. Right, so, all right.
This would be in the non-calculator section. Right?
Yes, this would be in the non-calculator section.